All right, everybody, welcome back to class. Obviously, I'm not here today. So today, we're going to start in section 6.6, and we're going to talk about finding rational zeros. Before we really start worrying about trying to find rational zeros, let's talk about what zeros of a function actually are. That means that your y value is 0. Okay, hence why it's called a zero. And if you are looking at a graph, this is where your graph crosses your x-axis. And if you are asking yourself, where have I heard about something crossing the x-axis? Yes, you have heard that before. Yes, it has come from me. We call that the x-intercept. Now, just to kind of show you what things are going to look like, I'm going to give you some polynomial function, maybe 64x cubed plus 120x squared minus 34x minus 105. And I'm going to ask you, what are its zeros? Now, obviously here, I give you the zeros, -3/2, -5/4, and 7/8. Now, what I want you to do is take a second here and look at -3, -5, and 7. And I want you to tell me how that is going to relate to this -105. Now, I don't know about you. I don't know a whole lot about 105 and 3, 5, and 7, how they're going to relate. Actually, that's a lie. I do. But, okay, you can take a look at those. Those are factors. So, -3, -5, and 7, they can all divide 105. Okay, if you don't believe me, grab your calculator, check it out. It works. Okay, that's not a mistake. Okay, now take a look at 2, 4, and 8. I want you to tell me how that relates to 64. Okay, maybe you've picked up on the pattern here. Your factors of 2, 4, and 8. Okay, all of these numbers divide 64. Now, it's not a coincidence that this just happened this way. Okay, this is actually what we call the rational zero theorem. If you have a polynomial function that has integer coefficients, okay, remember integers are all of your negatives, -3, -2, -1, okay, and that extends farther back. It includes 0, 1, 2, 3, and so far, okay, but no fractions, no decimals, none of that, okay, then every rational zero is going to have the following form. Factors of the constant term, okay, so the last piece in standard form, divided by factors of the leading coefficient, okay, the number in front of our biggest exponent. Okay, happens all the time. We're going to get very good at this. It's going to seem really weird. You guys are going to think it's way too much work. We're going to get practice with it. I'm going to give you some tips and tricks along the way about my process, and I will show you guys how these all work. So, simple question. Find the rational zeros of f of x equals x cubed plus 2x squared minus 11x minus 12. Okay? All of these are going to take factors of our constant term. So, I need factors of 12. Okay? So, numbers that multiply to 12, or numbers that can divide 12. So, I'm going to go 1, 2, 3, 4, 6, and 12. Okay, you guys get very good at listing factors. I like to list them in order. That's just kind of personal preference, just so it keeps me a little more organized. And now I need factors of our leading coefficient. So what number is in front of x cubed? I need factors of 1. Hopefully you guys got that. Okay? And the only factor of 1 is 1. So according to our factors of our constant term, or our rational zero theorem, we're going to take factors of our constant term divided by factors of our leading coefficient. Okay, with our leading coefficient being 1, we have made this a little nicer. So I'm going to list out my possibilities. With every one of these possibilities, I'm going to have plus or minus. Okay, the reason being, I could take -1 times -12. I would get a positive 12. That's fine. It just takes into account that I can work with both positive and negatives. So our rational zero theorem tells me that I need to divide factors of 12 by factors of 1. So I'm going to go 1 over 1 plus or minus 2 over 1 plus or minus 3 over 1 plus or minus 4 over 1 plus or minus 6 over 1 and plus or minus 12 over 1. So really, even though I'm dividing by 1, that actually makes things nice because now I'm just working with the numbers 1, 2, 3, 4, 6, and 12. I've got all my bases covered. So actually, instead of having 6 possibilities, I have 12. But you're going, geez, Mr. Vigdahl, I got 12 possibilities that I need to figure out if these are going to be zeros or not. That seems kind of rough. Okay? Yeah, well, 12 sounds a lot better than any number possible, any number that you can dream up. So I'm going to stick with my 12. Even if I have to check every single one of my 12, that's still a lot better than every number ever possible. So all we're going to do, now that we have our possibilities, we're going to check and see which one of these work. Okay? My strategy, and it's worked very well for me, I always start with positive 1. Positive 1 is going to be one of your possibilities in every situation because F1 divides every number. So I'm going to set up a little synthetic division, synthetic substitution here. 1's going up in the corner. I'm going to list my coefficients. I have every power of x, so I'm good. So I'm going to go 1, 2, -11, -12. Drop 1 below the line. 1 times 1 is 1. Add down. 2 plus 1 is 3. Times 1 is 3. I'm going to go -8 times 1 is -8, and I get -20. Okay? Since my last number is not 0, 1 is not a rational zero of this function. Okay? If 1 does not work, my next strategy every time, and this has worked very well for me, I try -1. Okay, it seems really silly. This has gotten me very far, and it's gotten me to narrow down my focus a lot more. And the more you guys do these, the more you'll kind of have a feeling of what you should and should not get. But this is kind of my strategy. Just because math books tend to like to put one of these in there, so. Drop my 1 below the line again, -1. I'm going to go 1. I'm going to go -1. I'm going to go -12 times a -1 gives me a positive 12, which gives me 0. And just like that, I now have one of my zeros. -1 is a 0. Okay, going back to what we talked about last class, we are going to, since it is -1, if I were to actually factor this, my factor would look like x plus 1. And remember, this is my constant term. I'm just going to put a C. This is my x term, and this is my x squared term. So I'm really working with x squared plus x minus 12. Now, I have found 1, 0. That's what I need. I've gotten it down to the point where I can factor x squared plus x minus 12. So my factors actually end up being x plus 1. And since I'm going to factor that, I'm going to set up 2 sets of parentheses. Okay, this is the same factoring you guys have been doing since Algebra 1. I'm going to ask myself, what multiplies to x squared? X and x multiply to x squared. Signs. I look in front of the 12. That is a minus sign. That tells me immediately I have 1 positive and 1 negative. Every time. It doesn't matter that there is a plus in front of the x. Now I need numbers that multiply to 12, to negative 12, and add to a positive 1. 4 and 3 multiply to 12. Positive 4 minus 3 is a positive 1. Now I just set these equal to 0. X plus 1 equals 0. X plus 4 equals 0. X minus 3 is equal to 0. And I can solve all these equations. And if I can write a little better, that helps. So I get that x equals negative 1. There's 1, 0. Subtract 4. I get that x equals negative 4. There's another 0. I add 3. I get that x equals 3. There's a third 0. Okay. Once you find one and get it down to the point where you have something that you can factor, an x squared, something like that, that's good. That's what you want. Now, what this tells me is that I could do my synthetic substitution, synthetic division, and if I would have negative 1, negative 4, or positive 3 up in the corner, okay, and obviously the negative 1 works, we did it. That's how we got to something that we could factor. Once I get there, I could have negative 4 or positive 3. I could do the exact same process. I would get 0 at the end. Okay? Now, those are my 3 zeros, and we are good to go. Now, let's take a look at this one. Now, this one should be a little skinnier on your notes handout. Okay, there's a reason for that. It's kind of a long problem. So if you write large, like I know some of you do, okay, you may want to get an extra piece of paper or find a way to write smaller. So we're going to find all the zeros of 10x to the 4th minus 3x cubed minus 29x squared plus 5x plus 12. Okay? Starts the same way every time. I need to find factors of 12. Okay? 12 is my constant term here. And hopefully you guys know the factors of 12. They are 1, 2, 3, 4, 6, and 12. If you don't know them, flip the page back. You don't even have to flip the page back over. Look at the problem before. We just did factors of 12. But now I need to go factors of 10. Those are going to be 1, 2, 5, and 10. Now, going back to our rational zero theorem, says we're going to take factors of a constant term divided by factors of our leading coefficient. So our possibilities. Okay, I'm going to go plus or minus 1 over 1, or plus or minus 1. I'll even write that out for you. 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 4 over 1, plus or minus 6 over 1, plus or minus 12 over 1. I get lazy with my comments as I go. So, but now, that only takes care of dividing by one of the factors. So I'm going to do the same thing with all the factors of 12 divided by 2. So I'm going to go plus or minus 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, plus or minus 4 over 2, plus or minus 6 over 2, plus or minus 12 over 2. Now, I realize some of these have already been done in some way, shape, or form. Okay, I list everything, make sure that I get them all. Okay, if I forget one, that could be a problem for me. Now, I've divided all of them by 2. I'm going to come back, I got to do it all with 5. Plus or minus 1 over 5, plus or minus 2 over 5, plus or minus 3 over 5, plus or minus 4 over 5, plus or minus 6 over 5, and plus or minus 12 over 5. And you guessed it, we got to do it with 10 too. Plus or minus 1 over 10, plus or minus 2 over 10, plus or minus 3 over 10, plus or minus 4 over 10, plus or minus 6 over 10, plus or minus 12 over 10. Okay, now that I have all of these listed, now I'm actually going to go through, I'm going to cross off my repeated ones. So, for instance, 2 over 2. It's the same thing as 1. Okay, I've already listed plus or minus 1, so I don't need that one anymore. Okay, but 3 over 2 I do need. 4 over 2, that's the same thing as 2. I've already got that. 6 over 2 is 3. Already have that. 12 over 2 is 6. Already have that. My fifths are all okay. Okay, 2 over 10 is the same thing as 1/5. Already have it. 4 over 10 is 2/5. Already have it. 6 over 10, 3/5. Already got it. 12 over 10 is 6 over 5. Already have it. You guessed it. Okay, so I took off, 8 of them, which is good. But as you can see, the more factors of your leading coefficient, that 10, the more possibilities you actually end up with. Now, you could go through and, again, my strategy, always try 1, -1 first. But because this is a video, I kind of want to try and save as much time as I can. I mean, I'm already, 17 minutes in, and we're not done with this last problem yet. So for the sake of time, I'm not going to have you watch me fail doing those. Okay? I'm going to tell you right away that one of your factors that you need to try is -3/2. Okay? I know. It seems weird that that's what I'm going to want to pick. Okay? Trust me, it works. So, -10, -3, -29, 5, and 12. Okay. Ooh. I'll be all right. Okay. Drop my 10 below my line. Take 10 times -3/2, and I end up with -15. -3 plus -15 is -18. Times a -3/2 is going to give me 27. I get a -2. Get a -3. +3. Signs make a difference. I get 8, and I get a -12 when I multiply 8 by -3/2. I get 0. So, now I have, what I have is I have x plus 3/2 times 10x cubed minus 18x squared minus 2x plus 8. I look at this, and there's no way possible that I am going to get these two to match by doing factoring by grouping. So now that I have all of these, you can go through and list out your possibilities again, but here's the deal. If you listed out factors of 10 and factors of 8, guess what? You're going to end up with a bunch of numbers that are already up in our possibilities list. Again, for the sake of time, I'm going to save you a little bit here and tell you what your next one's going to be. I'm going to put 4/5 up in the box. Okay, so I'm going to go 10, -18, -2, and 8. Notice, okay, these numbers are all the same from right up here, from our last synthetic division. Okay, that's not a coincidence. That's how it works. Drop my 10 down times 4/5 is going to give me 8. Add that to 18, I get negative 10, which will give me a negative 8, which gives me a negative 10, and again a negative 8 here, 0, and I have x plus 3 halves times x minus 4 fifths times 10x squared minus 10x minus 10. Okay, one thing you guys can do to simplify this for yourselves, divide all of these by 10. Okay, they're all divisible by 10. So really what you're working with is x squared minus x minus 1. Now, I don't know about you, but I don't know any factors of 1 that add to negative 1. That's pretty tough. So, since I don't know how to do that, okay, I'm going to go back to my quadratic formula to solve this. I'm going to go not x squared. Okay, quadratic formula. Okay, you guys all know the song. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And list out my a, b, and c. So a is 1, b is negative 1, c is negative 1. So I get 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 1 all over 2 times 1, which simplifies down to 1 plus or minus the square root of 5 all over 2. So we have zeros. At negative 3 halves, 4 fifths, and 1 plus or minus the square root of 5 all over 2. So these take a lot of work, but you guys are more than capable of doing these. I have full faith in that. It'll come to you. You guys will pick it up. Like I said, we're going to get lots of practice with this. So there's your homework. If you guys have questions, feel free to email me. I will try my best to keep up it on my email. However, you know, there's a reason that I'm not in class, so I may not get back to you right away, but I will try my best to keep up on that. Otherwise, ask questions to your classmates. Talk about it. We'll check this when I get back, and I will see you guys later.